All right, now we come to perhaps one of the most horrible topics for Calculus 1 students, and that are the optimization problems. These are word problems that are seemingly on steroids. I'm going to do a lot of examples to try to get you comfortable with them, but you'll have to do a lot of practice to get any good at these things. Many of my students, when confronted with one of these types of a problem on a test, simply leave them blank. I don't think they want to deal with them. Well, whatever the case may be, I'll go ahead and start with the easiest possible one I can think of, and I'll work my way up. So, we will start with this problem. What two non-negative real numbers with a sum of 23 have the largest possible product? So what two non-negative real numbers? So what I can do is I'll only write solution here. Let x and y be the numbers. So we know that they add up to 23 with a sum of 23. So x plus y equals 23. And we want to find the largest possible product. So let me write P equals xy. This guy right here, the product of xy, is what I'm trying to maximize. This is referred to as the objective function. Now, what you always want to do with the objective function is you're always going to find the absolute maximum or absolute minimum of it. Except you can't do it when it has two variables. You need to take two variables and find the connection between them to go to one variable. Look what I have here. Since x plus y equals 23, I know that I can rewrite the product as x times 23 minus x, because y equals 23 minus x. That's from this equation here. And the reason why I left a little space after the p is because now I'll put in parentheses x. The variable that I'm going to be having here will be x. So I want to find the maximum possible y value of this expression. We have some more information here. You were told that the two numbers were non-negative. So you knew, for one thing, that x was greater than or equal to 0. On the other hand, x cannot be bigger than 23, otherwise y would be negative, and both numbers have to be non-negative. So the biggest x can possibly be is 23. This is wonderful. We have a closed interval. A closed interval is guaranteed to give us an absolute max and an absolute min on that interval. We'll do the usual things that we were doing before. If I want to find the maximum, I'll go ahead and take the derivative. So p prime. Oh, actually, before I do that, I was thinking I don't want to use the product rule really. What I'm going to do is multiply first through by x. So I get 23x minus x squared. That makes taking the derivative very simple. P prime of x will equal 23 minus 2x. And you will go ahead and set that equal to 0. And then solve for x like you normally do. X is going to equal 23 over 2. This was a critical number. Now, there's several ways of determining if this is the maximum or not. One of the theorems that we have here, the absolute, I don't know if it's called what the theorem's name is, but it says you can find the absolute max or absolute minimum by looking at any critical numbers and the endpoints. So basically all I have to do is this. P of 0 equals 0 times 23 minus 0. That equals 0. P of 23 equals 23 times 23 minus 23, which equals 0. That means at the endpoints, this thing is 0. So whatever happens here has to be the absolute maximum. P of 23 over 2 equals 23 over 2 times 23 minus 23 over 2, which is going to equal 23 over 2 times 23 over 2, which, well, whatever that is, 23 squared over 4. That's the largest product that we can have. However, that is not what was asked. What was asked is what two non-negative real numbers. That means I want the values of x and of y. Well, if x was 23 over 2, y equaled 23 minus x would equal 23 minus 23 over 2, which equals 23 over 2. So the answer that they're looking for is 23 over 2 and 23 over 2. There's a second way you could have done this without actually using calculus. Instead, what you could have done is simply graph this function here, this parabola. So let me just say graphing version. Let's call it a graphing version. I'm done with the problem, but if I wanted to do this via graphing, I could have done this. We've already known that when x was 0, the function was 0, and when x was 23, the function was 0. Well, in a parabola, so this thing goes like this then. This is a downward pointing parabola. You should know that the highest point in the middle, the vertex, is located exactly halfway between any two points on a horizontal line of it. So that would occur at 23 over 2. This, now, had they asked you for the product, you'd look for this y value here, but it's not that important. In here, it's just asking for the x and y value, which is 23 over 2. So technically speaking, you could have gotten away without using any calculus whatsoever in this problem and just done this by graphing. I personally would advocate a way that allows you to do both. I would do the problem using calculus, then I would check with a graph to see if I'm doing it right.